What if the most dangerous star in our galaxy is not hiding in some distant, forgotten corner of the cosmos, but spinning right in plain sight? A cosmic time bomb ticking quietly beneath our very noses, its countdown invisible, and its power unimaginable. This celestial oddity is a neutron star, an entity so dense that a single teaspoon of it would outweigh the greatest mountains on our planet by billions of tons. To put this into perspective, if you scooped up a teaspoon of matter from this star and somehow brought it to Earth, it would weigh as much as Mount Everest multiplied by several thousand. This is weight beyond anything we encounter in daily life, so much so that it is difficult for even scientists to truly visualize. This begs a chilling question. If this star were to explode or collapse, could it endanger Earth? Is the next cosmic disaster actually closer than we have ever dared to imagine? But the neutron star's incredible mass is not its only extreme trait. PSR J0952-0607 sits balanced on a razor's edge of physical possibility. Just a tiny bit more mass, a fraction of a percent, an amount equal to the weight of a large asteroid, could force it to collapse under its own gravity, vanishing into a black hole. Scientists monitor it with bated breath, but the truth remains sobering. No one can say exactly when or even if that collapse will happen. For all we know, the fatal moment could have already occurred, and we are simply waiting for the evidence, traveling at the speed of light, to reach us across the gulf of space. To answer that, we must first understand what makes neutron stars, and especially this one, so uniquely perilous. The forces at play in these cosmic objects are not just lethal, they are almost beyond comprehension. Consider PSR J0952-0607, a name that might sound like a mere string of numbers, but represents an object that shatters every limit of what a star can be. This is no ordinary sun. This is an object that whirls at more than 700 full rotations every single second. Imagine that for a moment. In the time it takes you to blink, this star has completed hundreds of revolutions. In fact, before you even finish reading this sentence, it has spun thousands of times. Now, picture squeezing nearly 2.5 times the mass of our sun into a sphere only about 20 kilometers wide, smaller than the distance it takes to drive across most cities on Earth, like Paris, London, or New York. Imagine an object so dense, a single teaspoon would outweigh an entire mountain chain, and so fast, it spins more rapidly than any machine ever built by human hands. This is a neutron star, one of the universe's most extreme and mysterious creations. These are the densest, fastest, and most magnetic objects in the universe, outside of black holes themselves. Neutron stars are born from cosmic destruction. When a massive star exhausts its nuclear fuel, it dies in a cataclysmic supernova explosion. The outer layers of the star are blasted into space, but the core implodes. What remains is a sphere scarcely larger than a city, yet it contains more mass than our sun. This process is one of the most violent events in the universe, sending shockwaves that can be detected across interstellar distances. Let's break down the numbers. Inside that city-sized core, matter is crushed so densely that a single teaspoon would weigh over 1 billion tons. That is more than the mass of every skyscraper in New York City, condensed into something you could barely balance on your palm, if such a thing were even possible. If you attempted to pick up this teaspoon, the gravitational pull would be so strong that you would be crushed instantly, long before you even touched it. But the extremes of neutron stars go even further. Some neutron stars spin at speeds that defy the imagination. As they rotate, beams of energy sweep across the cosmos, acting like cosmic lighthouses. We call these pulsars. Some pulsars flash 700 times each second, with a regularity that rivals or surpasses even the best atomic clocks ever constructed by humans. The first pulsar was discovered in the late 1960s by Jocelyn Bell Burnell, who detected a regular, repeating radio signal that baffled the scientific community. At first, some even joked that it could be a signal from alien civilizations, so regular and precise was the timing. But it turned out to be something far more astounding, a spinning neutron star, beaming its energy into space in a focused jet. All these phenomena test the very limits of matter. If a neutron star gains just a bit more mass, or its internal balance shifts, it can collapse into a black hole in an instant. These are nature's ultimate laboratories, where physics is stretched to the breaking point. The stakes could not be higher. A single misstep results in a transformation so violent, not even light can escape its grip. But what if all these extremes are found in a single star? Imagine a pulsar spinning at the absolute limit, hoarding nearly 2.5 times the sun's mass, and teetering on the edge of collapse, a cosmic tightrope walk between existence and oblivion. Neutron stars can also become cosmic predators. Some have companion stars locked in their gravity, drawing matter from their neighbors in a deadly dance. As a neutron star feeds on its companion, it spins even faster and grows heavier. These are called black widow pulsars, named after the infamous spiders that consume their mates. In this deadly pas de deux, the pulsar feeds until it verges on a catastrophic threshold, devouring its companion star one particle at a time. What happens when the universe's most extreme star pushes its luck, flirting with oblivion for a second time? Among the most dangerous neutron stars are magnetars. These are rare variants that wield magnetic fields 1,000 trillion times stronger than Earth's. To appreciate that, consider that our planet's own magnetic field is enough to make compass needles point north and to shield us from the solar wind. Yet a magnetar could tear atoms apart and fry electronics from across the solar system. A single outburst from a magnetar can unleash more energy in 1/10 of a second than our sun produces in 100,000 years. In 2004, an explosion from a magnetar located 50,000 light-years away briefly altered the Earth's upper atmosphere and damaged satellites, a stark reminder of their potential reach. There is such a star in our own galaxy. Its discovery forces us to rethink the very boundaries of what is possible in our universe. It is a living experiment, a cosmic dare, pushing against the ultimate limits of physics. The result is nothing short of spectacular. The inner pressure falters. Neutron repulsion collapses. In less than a heartbeat, the entire star implodes. There is no explosion, no cosmic fireworks. One moment, its radio pulses beat like a metronome. The next, they are gone. A black hole forms in utter silence. Meet the astonishing PSR J0952-0607. This cosmic dynamo is the fastest spinning, heaviest neutron star scientists have ever found. It whirls more than 700 times each second, cramming nearly 2.5 suns worth of mass into a sphere no larger than a city. To grasp its density, picture again a single spoonful outweighing a mountain. If this star were placed in our solar system, its gravity would pull in and devour anything that strayed too close, warping space around it. But speed is not its most perilous trait. Hunger is. PSR J0952-0607 is a black widow pulsar, named for the spider that consumes its mate. It orbits a white dwarf, tearing away matter bit by bit. As it feasts, it becomes even heavier and spins even faster, creeping ever closer to a fatal threshold, the Tolman-Oppenheimer-Volkov limit. Cross that line, and the forces holding it together surrender to gravity. If these threats are so rare and remote, why should we care, or even bother to look up? This silent collapse might seem harmless, but the truth is more unsettling. As a neutron star becomes a black hole, it could unleash a torrent of gamma rays, or send ripples through spacetime as gravitational waves. If such a burst were aimed at Earth, even from across the galaxy, it could strip away our atmosphere, or trigger mass extinction. In 2003, astronomers detected a gamma-ray burst so powerful that had it occurred within 10,000 light-years of Earth, it could have ended all life. Yet the galaxy is vast, and the odds are vanishingly small. You are far more likely to be struck by lightning, win the lottery, and get attacked by a shark on the same day than to be hit by a cosmic blast from a dying star. The answer lies in what these stars reveal about the universe itself and our precarious place within it. Their very existence forces us to grapple with both the fragility and the resilience of the world we call home. Why should we concern ourselves with such distant, improbable dangers? Because cosmic monsters like PSR J0952-0607 remind us of the relentless, unforgiving laws that shape our universe. Earth's safety rests not on luck, but on a knife-edge balance of forces we have only begun to understand. What if the chaos of a neutron star was not some distant, abstract danger, but a real threat lurking just beyond our cosmic doorstep? Still, not all neutron stars wait for a quiet end. Some, called magnetars, are ticking time bombs of another sort. Their magnetic fields are trillions of times stronger than Earth's. When their crusts fracture in titanic starquakes, they unleash more energy in a blink than our sun emits in 100,000 years. These bursts can sterilize worlds from halfway across the galaxy. In fact, some scientists speculate that mass extinction events in Earth's history could, in principle, have been triggered by distant magnetar flares, though there is no direct evidence so far. A magnetar, wielding a magnetic field trillions of times stronger than Earth's, could do worse still. Its sheer magnetic power would shred molecules and tear the structure of matter apart. At close range, it could erase the planet's surface in an instant. No warning, no shelter, no hope. The rules of survival we trust would evaporate, overpowered by raw, cosmic energy. Science fiction has explored scenarios like this. In Arthur C. Clarke's The Star, a neutron star passes through a solar system, its gravity and radiation annihilating all life and civilization in its path. While such an event is overwhelmingly unlikely, the story captures the cosmic indifference and raw power of these objects. Picture a neutron star, or its even deadlier cousin, the magnetar, slipping quietly into our solar system. It would not need to come anywhere near Earth to wreak havoc. Even drifting as far out as the orbit of Jupiter, its gravity would begin to tug at the planets, skewing their paths, upending the delicate balance of our solar neighborhood. Radiation would surge outward, stripping atmospheres, boiling away oceans, and leaving only desolation in its wake. If it drew closer still, the devastation would escalate beyond comprehension. This is the universe as it truly is, not gentle, but wild and indifferent, shaped by forces that care nothing for life. Earth, with its tranquil oceans and golden sunlight, is not the rule. It is the cosmic exception. Most of space is chaos, not comfort. Safety is rare and always temporary. Yet even in this violent theater, there are survivors. Astronomers have discovered a handful of neutron stars orbited by planets, worlds that have withstood, or somehow returned to, the aftermath of stellar catastrophe. Some clung to life through the supernova blast that formed the neutron star. Others were snared later by relentless gravity. These rare planetary systems defy everything we expect about what can endure, and how tenacity sometimes outmatches disaster. For example, the pulsar PSR B1257+12 is orbited by several planets, known as pulsar planets, that somehow survived or formed after the supernova, their origins still a mystery. But to exist in such a place is to live on the edge of annihilation. The skies above these worlds are forever black, lit only by the lethal flicker of beams flashing from the neutron star. Every orbit is a gauntlet of invisible radiation, pounding magnetic storms, and shifting tides strong enough to crack a planet's crust. The environment is so extreme that simply existing is a miracle. And yet, improbably, a few worlds persist in these hellish realms. Recognizing just how fortunate we are changes everything. We live on a fragile island of order, set adrift in a sea of destruction. Our calm is a cosmic accident, not a guarantee. The astronomer Carl Sagan once remarked that Earth is a pale blue dot, a tiny oasis of life in a vast, dark void. So, after glimpsing the power of neutron stars and magnetars, should we lie awake at night, fearing that one may come for us? The answer is both reassuring and humbling. While the odds of such an encounter are vanishingly small, understanding these dangers reveals just how fierce and bizarre the universe can truly be. Should we lie awake, haunted by thoughts of a star spinning itself to death? Or is there something more profound, something vital to learn from these wildest citizens of the cosmos? Let's face the truth directly. No matter how extreme, volatile, or fast-spinning neutron stars and magnetars become, the odds of one harming Earth are astonishingly low. Our galaxy is so vast that these monsters are almost always distant, far from our solar neighborhood. Even when they erupt, unleashing blasts of radiation or catastrophic starquakes, the chance that Earth feels the impact in any significant way, especially within our lifetimes, is virtually non-existent. The true value in studying these cosmic extremes goes far beyond fear. It is about perspective. Neutron stars and magnetars are reminders that the universe operates by rules, forces, and energies far beyond what we encounter in daily life. Their violence and instability are the norm, not the exception, when you zoom out to a cosmic scale. Our own solar system, with its gentle sun and reliably stable orbits, is a rare oasis in a universe built on chaos. The calm here is the anomaly. Elsewhere, destruction and unpredictability reign. The universe does not promise safety. We have simply been unimaginably fortunate, so far. Dramatic events like gamma-ray bursts and sudden stellar collapses do occur. But on the scale of a human lifespan, they are so rare and so distant that fearing them is like dreading lightning striking the same tree twice in 10,000 years. The universe's most dangerous spectacles are breathtaking, but for us, they are just background noise. Extraordinary, yes, but not a reason for panic. But what does it take for a neutron star to truly cross the line, from spinning beacon to black hole? To understand that, we must look even closer at the brink of collapse and the practical steps scientists take to study these events. When scientists peer into the hearts of these monstrous stars, they are really testing the boundaries of physics. Each pulse and every outburst offers new clues about matter, gravity, and magnetic fields at their most extreme limits. By understanding these cosmic dangers, we sharpen our science, humble ourselves, and become better prepared for the rare day when such threats might actually reach us. Even more than that, these discoveries deepen our gratitude for this fragile blue world. Against a backdrop of relentless cosmic violence, the fact that we can stand under the night sky and gaze upward without fear is an improbable gift, a statistical miracle. Our existence is a testament to the resilience of life and the rarity of stability in the universe. Ultimately, the universe's wildest objects do not threaten us so much as they ignite wonder. They keep us aware of the razor-thin line between chaos and calm, and remind us how much we still have to learn about the forces that shape not only the cosmos, but our very existence. The study of neutron stars has led to advances in technology and understanding, inspiring innovations in materials science, nuclear physics, and even medical imaging. To stand on the brink of disaster is its natural state. One day, it may collapse, becoming a black hole and unleashing forces we can hardly imagine. Yet if we focus only on the threat, we miss the deeper revelation. These stars are not just harbingers of destruction. They are the universe's own experiments, exposing the laws that shaped everything we know. So, When you gaze up at the night sky, let each glimmer remind you, the universe is not merely a realm of threats. It is a place of endless discovery and breathtaking strangeness. The real danger is not the star that might explode, but failing to recognize the wonder all around us. The edge of the galaxy is not merely a frontier of distance, it is a frontier of physics. There, a star spins so quickly, so fiercely, that it nearly tears itself apart. This is not a distant myth. It is PSR J0952-0607, a neutron star whirling more than 700 times each second, its mass close to 2.5 times greater than our sun. This star is a cosmic dare, proof that the universe can push matter to its very limits. Earth's safety is not promised, but it is astoundingly rare. Our planet drifts in relative peace, shielded by vast stretches of emptiness and luck beyond calculation. The odds of a neutron star endangering us are so impossibly small, you would have to be struck by lightning every single day for 1,000 years to even come close. But knowing these monsters exist changes us. Instead of shrinking from fear, we can stand in awe. These extreme stars are among the universe's most powerful laboratories, compressing the rules of time, gravity, and matter into a single, spinning point. Each one is a lesson in how reality bends, holding secrets stranger than fiction. This is our place in the universe. Not victims of random violence, but explorers and students of the wildest realms. The universe's most dangerous star is not merely a threat. It is a beacon, calling us to greater understanding, greater appreciation, and a deeper sense of awe. In confronting cosmic peril, we become more resilient, more knowledgeable, and, perhaps most importantly, more grateful for the improbable peace we enjoy on this pale blue dot. The next time you hear of a star on the verge of collapse, do not ask when it will end. Ask what it can reveal about the miracle of our own existence, here, now, in this fragile moment. What practical steps can we take to learn more? Scientists use a variety of tools: radio telescopes to catch the pulses, X-ray satellites to track high-energy outbursts, and gravitational wave observatories to listen for the faint echoes of stellar collapse. Each new instrument sharpens our view, making the invisible visible, and turning cosmic threats into cosmic lessons.